Now, what will you see in your this revision package when you download it, right? Is that you would see a list of compiled formulas and definitions. So this is super good. Imagine like the day before end of year and you just want a quick revision of all the definitions. You can find it here. I think I gave you guys for the definitions up to general wave properties. Okay. And then in the second half here, you'll see a couple of questions. Now, the questions you see here are the questions that we are doing for today. I've made it a point to include the answers, all right, because I know not all of us have the bandwidth to write down and listen at the same time. So I already wrote down most of the solutions, which means you don't have to be in a rush to copy it later on. Instead, right, focus on hearing my explanation and the additional stuff that I share, you can add it in. So every single question here we'll be going through around 4 questions per topic. All right. So I hope that you guys have a better sensing of what's going to happen. We'll probably take a break in the middle. And more importantly, right, at the end of the session, right at the end, okay, like the last 10 to 15 minutes, we'll be doing a Kahoot. And the winner of the Kahoot, right, will walk away with one set of physics curated notes. All right. So only the winner. So there's no tight place or whatever. Okay. But I know most of you here will probably be Sec 3s, but I know some of the Sec 4s here are probably joining in for revision. I have no issues with that at all. But later for the Kahoot itself, please allow the Sec 3s to participate, because if the Sec 4s participate, a bit not fair, right? Because you already know the stuff. So very easy to win. So instead, let's make this competition a fair one for the Sec 3s, because this is meant for the Sec 3s. Then among the Sec 3s, we'll see who's the winner. Okay, so maybe I'll start off with a quick introduction about myself. So hi everyone, this is me. Okay, I'm Daryl. I've been teaching for quite a while now. I thought right after I graduated A-levels and entered army, I started teaching. That was in 2014. So this is my 9th year teaching already. So I've teaching mainly chemistry and physics. So if you're attending the chemistry one tomorrow, you will see my face again. Okay. Now, what else do you want to know about me? I mainly just teach upper sec. This year, in fact, almost all my students are Sec 4s. So I have 100+ students with me right now. I'm low-key dying, but also very excited for them to go on to challenge O-levels and stuff. If for students that attended the crash course and stuff, that is also me as well. So I'm mainly the chemistry and physics guy. All right, so I'll share a little bit more about all of the tuition stuff later if you're interested. But let's just jump straight into today's focus, which is going through the 3 chapters. So what you see here on the screen right now is the soft copy of the curated notes. For all my students that are joining or in my tuition classes, they'll receive a copy of this. You can also purchase a copy of this on the website lah. But the point is that I'm going to use the curated notes to be teaching 4 chapters today. We'll be talking about kinematics. We'll be talking about forces. After that, we'll take a short break. In the second half, we're going to be going through moments and work energy power. If your question is why am I not covering more, it's because I only got 2 hours. Okay. So, but trust me, the next 2 hours is going to be really productive. There will be a lot of things here that you learn that your teacher might not necessarily emphasize or teach in school. All right. But this is based on my own knowledge and what will really help you out. So listen closely, and some of the things that you want to take down, please write them down. Okay. Let's jump straight into kinematics. All right. So kinematics is definitely one of those topics that you will get tested at end of year. But I think more importantly here, what are the kind of things you need to look out for in this chapter? Now, one very important thing to start off with is, do you know what's the difference between a scalar and a vector? Now, that itself is not very difficult. When we say scalar, it just means it only has magnitude, while a vector quantity, okay? Vector quantity typically has both magnitude and direction. Now, while this might seem easy enough, later on, I'll show you a question, right, that would really test you on your understanding of this. Now, as we are talking about distance and displacement, they are both a measurement of the length in meters. But what is the difference between the two? Distance is a scalar quantity that only has magnitude, meaning I don't really care about the direction at all. Meanwhile, for displacement, I do care about the direction. The best way to think about displacement is usually the start point to the end point. So normally, for a set of movement, you start somewhere, you end somewhere. If you connect a straight line from the start to the end point, That itself is what we call your displacement. Meanwhile, distance is literally how much you travel. So you need to understand that for displacement, we do care about the direction. Now, I give you a very simple example. You know, when you're running your 2.4 NAFA and stuff, you run one round around the lap, right? So typically on the track, one round around the lap is 400 meters, correct? So the distance you have ran in one round is 400 meters. But how much is your displacement after finishing one lap? Is it 400? No, right? In fact, your displacement is exactly 0 meters. Why? Because if you are actually running around the track and you go one round, you actually end up at the same position again. Since your start point and end point is at the same position, your displacement is 0. So please remember displacement, we do care about the direction. Now, what's the relationship then between speed and velocity? Just understand that when we say the word speed, that is the rate of change of distance. Meanwhile, displacement is used for velocity. So both displacement and velocity are vector quantities that take into account the magnitude and direction. Now, for definition wise, right, I need you all to be super careful here. If you're going to go with the definition, speed is the rate of change of distance. You can do that, but you're not supposed to write rate of change of distance per unit time. So please understand that rate of change is inclusive of the term per unit time. So if you write rate of change of distance per unit time, you are actually wrong, because that is repeating it. That means you are actually dividing by time twice. So you don't want to be doing that. So you either do rate of change of distance or you do change in distance per unit time. Either or, you do not write both. Okay, so this pretty much establishes the idea on distance, speed, displacement, velocity. Now, a simple example here that I want you all to take a look at, which is we have two people walking towards each other. While the speed might be exactly the same, you want to observe here how velocity, there's a positive and a negative. Because in a question, they will usually tell you which direction is positive. Since Amy is walking towards the right side, her direction is towards the positive side, her velocity is positive. But David walking in the opposite direction, his velocity is negative. Speed will never be negative, okay? Because speed, we are only caring about the magnitude. There's no direction. But velocity can be negative. And I'll talk more about the impact of this later on when we are trying some questions. Now, let's take a look at what else we need to know. We need to know what the average speed and how do we calculate it. Take note, there's only one way to calculate average speed, which is total distance over total time. Now, I think pretty straightforward. Now, using this example, there's only one thing I'd like to teach you here, which is when you are dealing with average speed versus average velocity, please do not assume that the values will be the same. Okay, sometimes it's the same, but sometimes it is not. Now, what we have here is a velocity time graph. If you see the graph and it's above the x-axis, this whole area here, this is traveling in the positive direction, meaning it's traveling forward. But if you see your graph is below the x-axis, it means it's traveling in the reverse direction. And what is the significance to your average speed and average velocity? Observe here how for total distance, do I care about the direction? I don't care. You move forward, you move backwards, it's the same for me. So here we see a plus sign. Even though from 8 to 12 seconds, the car is moving backwards, I don't really care because total distance is literally how much I travel. The direction is irrelevant when it comes to distance. But when we are talking about total displacement, do we care about the direction? We do, right? Which is why here, what you're doing is you're taking the distance traveled in the forward direction, minusing the distance traveled in the negative direction. It gives you a different value for displacement, hence your average velocity will be different. So summarize, what do I need you to take away from here? Average speed and average velocity are not necessarily the same thing. In fact, they could be very different. Clear? And the formula is pretty straightforward. Distance over time, total displacement over time. All right, so that's all you need to know in terms of speed and velocity. Now, let's move on. Acceleration is pretty much the rate of change of velocity. The easiest way to visualize acceleration is imagine your car entering the highway. Normally on the highway, you can drive a bit faster, right? So when the driver presses down on the pedal, the car starts to accelerate. We usually associate acceleration with an increase in speed. And the decrease in speed obviously is known as deceleration, right? So deceleration means slowing down. And inherently, deceleration will be a negative acceleration. So if you get a negative acceleration, it's the same thing as saying deceleration. All right, so don't be too shocked when you see the values. Can? All right, if not, this is where I really need your full attention. All right, what we are looking at here is the displacement time graph. And later on, we'll be looking at the velocity time graph. If you're being tested for kinematics, likely either one of these will appear. Now, what do I need you to remember? Number one, if what you're dealing with is displacement time, remember this, your gradient represents your velocity. Okay? Now, I know some teachers might get you to just memorize this. Oh, displacement time gradient represents velocity. But honestly, this is something that we can easily understand if we just put the pieces together. Here we have our y-axis, which is displacement. Our x-axis is time. Remember how we actually calculate gradient? Gradient can be calculated by taking y over x. And if I put my y over x, displacement over time, I want you to see that displacement divided by time is equivalent to velocity. So is there really a need to memorize this, that the gradient represents velocity? Actually, if you know displacement over time, y over x is gradient. Gradient here will be velocity. That's all. Okay, so let's take a quick look at some of the words we use to describe this whole thing. Can you see from 0 to 2 seconds? It's a straight line. This is a positive constant gradient. We replace the word gradient with velocity, aka constant velocity. At 2 to 4 seconds, my gradient is 0. If my gradient is 0, velocity is 0, my object is at rest. And of course, as we are seeing a negative gradient, we can quite clearly see that here a negative gradient means is a decreasing velocity. Okay, and definitely it will be in a reverse direction. Now, I know some of you will be very confused when you see this word decreasing and constant velocity. Now, constant velocity should be okay, right? Because we see here, this is a gradient that is constant. So constant velocity. But more importantly, because it's moving in the backwards direction, right? It was at 50 meter, and then it went down to 0 meters. So it's traveling in the reverse direction. But what about this decreasing velocity? In order to determine that, what you are required to do is to actually plot in and draw in the tangent to the graph. So if you take a look here, if we draw in the tangent, can you all see that the gradient is actually getting gentler and gentler? Which is why if your gradient is decreasing, we can claim that your velocity is decreasing. That's all. So what's your final takeaway from this? Gradient represents velocity. That's all. All right. So the thing here is that most of the time, what you actually be tested is the velocity time graph. Now, for velocity time graph, there are two things you need to know. And obviously, you can see them in the notes here, right? Gradient represents acceleration. Area underneath the graph represents displacement. So earlier, actually, we touched on this briefly, which is how I talked about area x, right? Right. I say area x was traveling in the positive direction. However, area y is traveling in the negative direction. So if you calculate the area underneath the graph, it will give you an idea of the displacement. If you're calculating displacement, you take area x minus area y, because area y is traveling in the reverse direction. But if you're calculating distance, we'll add the two up. Same idea as y over x. Velocity over time, the gradient represents your acceleration. Okay, but don't worry about this. We're going to go to some questions instead. Okay, and to finish up this chapter, what is really important, number one, is understanding that all objects on Earth experiences gravity. Okay, and how much is gravity? Gravity is a value of 10. Air resistance, I think we all understand how this works. Remember that air resistance will increase when speed or surface area increases. Give you two simple examples. When you are walking, okay, to the bus stop, okay, you can gently feel maybe a bit of wind sometimes. But assuming that the wind condition didn't change, you see your bus arriving or your MRT arriving, you start running. When your speed increase, your air resistance will increase. Imagine as you're sprinting towards the bus, can you visualize that it's wind blowing, right? You feel that gush of wind. That itself is how we know that air resistance increases when speed increases. Surface area, even easier, right? National Day 1 month ago, when they open the parachute increases surface area, air resistance increase, the parachutist actually slows down. Okay, so two things affect air resistance, the speed and the surface area. Now, one of the final things we want to talk about today is terminal velocity. Now, what is terminal velocity? The keywords here are very important. Okay, hint, pay attention because this might come out later in the Kahoot. Now, how does terminal velocity occur? Air resistance will increase when velocity increase. Remember, we just talked about it. There are two factors that affect air resistance. So when velocity increase, air resistance will increase. Eventually, it will hit a point where the air resistance is equal to the weight of the object. Now, what exactly happened here? If you take a look at the diagram that I'm drawing, we know that all objects that have mass will have a downward force, which is the weight. And what will oppose the weight is the air resistance. Now, as we continue to fall, our speed increases, as we can see here, right? Your speed keeps increasing. But you need to understand that when your speed increases, your air resistance will increase as well, until a point whereby your air resistance and weight is equal. When that happens, the both of them will cancel one another out. Your resultant force becomes zero. Since F equals to ma, if you have zero resultant force, you will have zero acceleration. Zero acceleration means my body would now start to move at constant velocity. This constant velocity that you're traveling at is otherwise known as terminal velocity. Can? So I run through one more time. Air resistance increase when velocity increase. It will eventually hit a point whereby your air resistance and the weight is the same. When that happens, they cancel each other out. Your resultant force on the body is zero. Zero resultant force, F equals to ma, zero acceleration. When you have zero acceleration and you're moving at constant velocity, that constant velocity is known as terminal velocity. Okay, if not, right, what's going to happen next is that we are going to jump and take a look at some questions with it. Okay, Xavier, for the parachutist graph here, is near impossible to calculate the area underneath the graph because it's a curve. Normally, if you are going to be tested on how to find the distance and stuff, they should give you a straight line or some versions of a straight line that you can calculate the area underneath. Okay, Joycelyn, why would air resistance be equal to the weight? Now, you need to understand that weight is a fixed value. Let's say my object is 5 kg. My weight would be 50 newtons, because W equals to mg, right? 5 times 10. Okay, so my weight is 50 newton. At the start, maybe my air resistance is 0 newton, right? Because I'm not moving yet. But as my speed starts to increase, my air resistance will start to increase. Maybe after a while, the air resistance is 10 newton, then increase to 30 newton, until it hits a point whereby when it hits 50 newton, that is the critical point whereby the weight and the air resistance is equal. That is when your resultant force will be zero. Why would the air resistance increase? It's because of this. Air resistance increases when the speed of the object increases. Okay? Now, how can we find the terminal velocity? You do not find the terminal velocity, but rather you locate it. Once you see this dotted line here, when your velocity is constant, that is when you. Just now somebody was asking me what happens when the parachute opens, right? So parachute open very easy. When your surface area greatly increases, that is when your air resistance will greatly increase. When your air resistance now is greater than your weight, this point here, we simply call it deceleration, right? Because if I'm jumping off, right, and then I parachute, when I open up my parachute, I would drastically slow down. So that is known as deceleration. Okay, meaning you used to be dropping at maybe 100 meters per second. Shit, that's quite fast. 50 meters per second. That's still quite fast. Okay. But then maybe you slow down to 10 meters per second, which is why it's very important for people to open the parachute quite amount of time before they land, so that when they land, the speed is not that high. Okay. But normally after you open your parachute, you will enter a second terminal velocity. Okay. But obviously this second terminal velocity will be a lot slower. All right. So to summarize, this chapter, okay, one question, retardation, deceleration, similar. Retardation and deceleration are just different definitions of the same thing. It's about slowing down. Okay, but good question. Now, so summarize what you need to know about this chapter. Number one, you need to know the difference between distance displacement. Okay, wait, I go to the revision package. You need to know the difference between the term distance versus displacement, scalar versus vector. Okay, then you need to know the difference between speed, velocity. You must be able to calculate acceleration, as well as you need to know how to talk about terminal velocity. What is not given in this definition sheet is the kind of questions that you'll be tasked to solve, which is your velocity time graph and displacement time graph. Okay, I see very good questions on the chat. Now, let's try to answer them one by one. First question, does having a higher terminal velocity means the object would fall to the ground first? Answer is yes, assuming both objects start from the same height. The higher your terminal velocity, you're moving faster, definitely you'll reach the ground faster. Next question, heavier objects, will they reach the same terminal velocity? Fair point. So for heavier objects will have a higher terminal velocity. Okay, now why is that the case? It's because here, if my object is heavier, maybe instead of 50 newtons, let's say it's 100 newtons. Okay, that means my object is 10 kg. How much air resistance will I need to completely cancel it out? I need 100 newtons of air resistance. If I were to draw out a speed time graph, okay, or velocity time graph, this is how it will look for the 5 kg object. It hit terminal velocity somewhere around here. But for a heavier object, it will take a longer time to hit terminal velocity, and it will hit a higher terminal velocity. Okay, wait, I try my best to sketch this as good as I can. Okay, if you are having writing materials, I suggest you draw this with me too. Okay, I know my sketching is not the nicest. I failed art and craft, by the way. But the idea I'm trying to show you here is that it will hit terminal velocity at a later time, and the terminal velocity would be at a larger value. Okay? So this is the 10 kg object. So the heavier the object, it will take a longer time to hit terminal velocity, and it will hit a higher terminal velocity as well. Okay? Initial velocity for all objects, regardless of weight and surface area. Initial velocity, no. Initial acceleration will be the same. Okay, but I'll talk about this soon. So, I mean, you guys are asking great questions, but I have to move on first to the ones in the worksheet. Okay, so let's take a look at the ones that we have here. Okay, then if we have time, I'll go back to your questions. Wow, people, why are you so smart? You're asking really good questions. I like it. Okay, but let's take a look at this diagram first. So this is actually a TOS question, in case some of you can recognize it. This is our Singapore flyer. Now, the question is saying that, okay, this cabin thingy, right, this spoke, right, is moving at constant speed. Then they're asking what happens to the velocity. Now, some of us might be thinking, okay, constant speed, right? The magnitude did not change. So velocity should be constant as well. Now, you need to recognize what's the difference between speed and velocity. As we have mentioned earlier, speed is a scalar quantity where I only care about the magnitude. But for velocity, it is a vector quantity. Can see S and S, scalar, speed. V, velocity, vector. Vector quantities cares about both the magnitude and direction. As the Ferris wheel is turning, the Singapore Flyer, is it a Ferris wheel? Yes, right. It's turning. Okay. While the magnitude was the same, right? The speed is constant. The direction is constantly changing. Which is why here the answer is that velocity is constantly changing, not because the magnitude changed. The velocity's magnitude was never changing. It was always the same, but the direction is constantly changing. So here, your velocity is changing. In other words, you can say that it's undergoing acceleration. Okay, I know this might be a bit counterintuitive, because some of you might be like, huh? The speed is the same, how is it undergoing acceleration? That is when you need to remind yourself. Acceleration is a vector quantity. Yes, increase in the speed, which is increasing in magnitude, is acceleration. That is how we usually think about things. However, you need to take into account the direction matters as well. Something with a changing velocity means it has changing, that means it's undergoing acceleration. Okay? So remember, there's two parts to a vector quantity. Is the magnitude changing and is the direction changing? Right? Because normally when we say acceleration, we're very narrow-minded. We just like, okay, it means in a straight line, I go faster. Right? For example, a car accelerating. That one is just increasing the magnitude. But when you change the direction, something's velocity will change, meaning it undergoes acceleration as well. So remember, magnitude and direction. Okay, I see some of your questions, but I will only elaborate on them if it's relevant to the learning point I'm trying to emphasize. Okay, so don't feel heartbroken if I don't answer some of your questions, okay? Because if not, I cannot move on because we have a big group here. I want to make sure everybody learn as much as possible. So if your question is relevant to what I'm trying to teach, then I'll answer it. If not, I will talk about it probably after when I have a bit more time. Okay. Clockwise is about the clockwise moment. Direction is definitely changing because if we plot in at different parts, can you see the direction of the movement is actually, the direction is changing. Okay, clockwise is clockwise moment. So it's not exactly the same thing as direction. Okay, next up, question 8. I'll just give you 30 seconds to read through. Then I'll talk about what is the most common mistake versus what is the correct way of solving this. Joycelyn, yep, direction of your velocity is changing, but magnitude is constant, which still means your velocity is changing. Your school didn't teach this in detail, right? Confirm. But it's okay, I'm here to teach you guys that. Xavier, I think we will just keep it as a simple one as it undergoes acceleration. We are not trying to calculate the value of your acceleration here. That's not the purpose of this question. This is not a v minus u over t situation. Okay, so you just need to know changing velocity means undergoes acceleration. That's all. Okay, let's take a look at question 8. Question 8, what we have is car P and car Q. Now, car P started at 0 speed, but car Q started straight away at 4, right? So in the first 2 seconds, area traveled by P is distance traveled by P is the area underneath the graph. Meanwhile, distance traveled by Q is the area underneath the graph of Q. Now, the question is asking at what time would one car pass another? A lot of people, when they first do this, they would think it's 2 seconds. Why? Because at 2 seconds, both car P and car Q have the same velocity. But please remember, when they have the same velocity, it doesn't mean car P and car Q would pass one another. Now, what do I mean? Let's take a look at what happens in 2 seconds. Okay, in 2 seconds, how much have car P traveled? We are calculating that by looking at the area underneath the graph. So what is the area underneath the graph here? It is this triangle. Half base times height, P would have traveled exactly 4 meters. In 2 seconds, car Q would have traveled, area underneath the graph for Q is this entire rectangle. So how much is that? Car Q actually traveled 8 meters. So at the 2 second mark, at this point in time, car Q is ahead of car P. So will the cars pass each other? Definitely not. P is still trailing behind Q. Now, when will the car pass by one another? It's actually at the 4 second mark. Now, why is that the case? Let's calculate the distance traveled by car P in 4 seconds, which will be equivalent to your area underneath the graph. So your area underneath the graph in 4 seconds is this triangle. Half base times height. Quick math. How many meters? 16 meters. Okay, half base times height. Okay, I trust you guys can do half base times height. Okay, but how much distance is traveled by car Q? It is area underneath the graph. Car Q's velocity was constant throughout. It traveled at 4 meters per second for 4 seconds. Area underneath the graph is 16 meters. When both cars travel the same distance, that is when car P would catch up to car Q. So car P would pass by car Q at the 4 second mark. Answer here is D. Can? All right. So I think this is another one of those tricky questions. Just remember, don't be that blur sotong that says 2 seconds. Okay, 2 seconds is when the speed is the same. It's not when the cars will pass one another. Okay. On the other hand, at 4 seconds, the distance traveled is the same, which is when they will actually officially pass one another. Okay, moving on. If this was changed to a speed time graph, it would still be the same answer. Okay, but fair question. Now let's take a look at this question. This is very common. In fact, this is the same one that I was indicating in the curated notes as you all saw earlier. Now, first thing you need to remember is that as long as they are both on the same planet, Earth has a gravitational field strength of 10 to a power of ms minus 2. So all objects on Earth, regardless of shape, size, and weight, will experience the same initial acceleration. How much is it? 10. So the moment something is being dropped, they will all experience the same initial acceleration. But when you're comparing the two objects, the object that is heavier has greater weight, meaning you need a greater amount of air resistance to cancel out. Okay, so you might want to write this down. Heavier means weight increase. It also implies that your air resistance to cancel increases. So you all remember the graph that I drew out for you earlier? The very ugly looking one. Okay, I'm going to try again to make it look nice. Don't laugh at me if I fail, okay? Okay, a bit better, not much difference. Okay, but my point is if you are a heavier object, there are two things. It will take a longer time to hit terminal velocity, plus it will hit a higher terminal velocity. If you think about it, it makes sense, right? Because let's just give it a hypothetical value, right? Object 1, which is 5 kg, will take 5 seconds to hit terminal velocity, while object 2 would take, say, 12 seconds before it hits terminal velocity. The longer you're undergoing acceleration or free fall, you can accelerate for a longer period of time. The final speed that you'll hit will be higher. So the point here is simple. If you are allowed to accelerate for more time, the terminal velocity that you'll hit will be a larger value. Okay, so you might just want to write this down because this here directly explains why your answer in your revision package here is C, because the heavier object will have a higher terminal velocity. Can? So maybe I just go back here for those who are planning to sketch this out. I think this is a very good visualization, especially when you're revising how is terminal velocity being affected, okay, by your weight. Okay, moving on in 30 seconds. Okay, let's push on and take a look at this question as well. This is a very famous question. Now, you need to recognize that here the graph given is height and time. This is not a velocity time graph. This is effectively a distance time graph. And what does the gradient here gives you? Gradient of a distance time graph gives you the velocity. When we use the term terminal velocity, this is when your speed is constant. So in other words, you can be observing how it changed from 1 second to 2.5 seconds. This part where it's straight, where the gradient is constant, is when you're experiencing constant speed. So what is the value of the gradient itself? You can take your y-axis over your x-axis. y1 minus y2 over x1 minus x2. So what is your values? Your y is from 3 meters to 0 meters. Okay, then here is 1 second to 2.5 seconds. So in other words, 3 divided by negative 1.5, it's 2.0. Okay, but here, as we are looking at the value, they are just concerned with the final value itself. So the negative direction here is not important. Okay, which is why the final value should be D. All right, so if you get a distant time graph, remember, gradient represents velocity, then you'll be fine. All right, we are good with kinematics. So let's move on to the next chapter in dynamics. So dynamics is just force, so don't be too confused with the way it's called. So basic stuff, force is a vector quantity, unit is Newton, force should have direction, it should have magnitude. Now, there are a few types of forces you need to be able to identify. Weight is always acting vertically downwards. Tension would be always against the thing you're pulling. So weight is down, tension's up. Normal reaction force will always be 90 degrees to the surface you're resting on. Friction will always go against the motion. All right, so you need to be able to see the different forces that were labeled here. Now, let's start off with Newton's first law. Okay, there are 3 laws in total. Now, the first thing I need you to remember is that you do not need to memorize the laws. Okay, it's stated in your O-level syllabus that what you are required instead is to apply the laws. Okay, so you're supposed to apply it, not memorize it. Now, does memorizing it help? It does, because you need to memorize first, then you know what it is, then you can apply. But at O-level, they'll never ask you to say, state Newton's first law. There's no definition question like that. But instead, they'll be testing you on different situations where you can apply it. Okay, Shane, tension is different from normal reaction force. Tension usually exists in the rope or the string. Normal reaction force is the force exerted by the ground you're resting on your object. Okay, so one is in the string, the other one is from the ground on the object. Now, what do we need to know about Newton's first law? Newton's first law states that an object at rest will remain at rest. Object in motion will continue in motion unless an external resultant force acts on it. Now, the best way to think of Newton's first law is by associating it with the term inertial. Now, what does the word inertial mean? Inertial is the tendency for a body to continue in a state of rest or motion. Meaning, if an object is not moving, it doesn't want to move. For an object that's already moving, it doesn't want to stop. The best way, right, that I always tell my own students to remember it is just think of the word momentum. Right? Momentum is a word that we kind of understand how it works, right? For example, right now you haven't started studying for your end of year exams, right? Is it very easy to get started? No, it's freaking hard because you don't have the momentum yet. Meanwhile, somebody that say Usain Bolt when he's running, right? As he passes the finishing line, does he stop immediately? He doesn't, right? His momentum brings him forward. He runs for another like 50 meters while doing his famous pose, right? So what is momentum? I haven't moved. I don't want to move. If I'm really moving, I don't want to stop, right? So that is the whole idea of inertial. And listen carefully, yeah. Inertial only depends on one factor and one factor only, and that is the mass. Weight, density, volume, gravitational field strength, nothing affects inertial except for the weight. Sorry, except for the mass. So there's only one thing that inertial is dependent on, the mass. So for questions that come out, right, they'll try and confuse you. They'll write a lot of different things. But all you need to remember is that the mass is the one that affects your inertia. Okay, so that is Newton's first law for you. Newton's second law, we don't have to think too hard. It is simply F equals to ma. But as I teach all my students, right, my own students, they don't think of it as F equals to ma. I always encourage Rf equals to ma. Why? Because the F here is not just force. It is resultant force. And how is this significant? Let's use a question to explore why we need to remember the term resultant force. Okay, so let's head over to this question. Okay, why is resultant force important? So here we have a cable of a crane used to lift a load. So I always like to draw it out. So here, right, my object is 500 kg. They were even nice enough to tell me that the weight was 5,000 newtons, right? The cable exerts a tension or a force. Here, the tension is 7,500 Newton. Now here, they want to find acceleration. Of course, right, anybody can tell me it's F equals to ma, right? Like obvious, right? Confirm F equals to ma. But you realize there's a problem here, right? If you just say F equals to ma. Do you use the 7,500 to calculate? Do you use the 5,000? What's the outcome? This is when the power of Rf comes in. If you remember it's Rf, you would then remember that what you need to do is to calculate the resultant force. Now, what is resultant force? Resultant force is simply the result, the final result. So all you need to do is to take the bigger minus the smaller. So the resultant force here is 2,500 newtons in the upward direction. Now, we then use the resultant force to calculate Rf equals to ma to find the acceleration. Can? So remind yourself for your upcoming end of year, if you get a question for force, don't be so naive to think that, oh, F equals to ma. Actually, F equals to ma, you don't study, you also know the formula. But the key difference, right, between those that got study and those that didn't, is that we understand it's not F equals to ma. It is Rf equals to ma. Resultant force, not just the force. Clear? So Newton's second law seems very straightforward on the surface, but deep within, you need to understand it is resultant force. Okay, lastly, Newton's third law. Now, Newton's third law is probably the most tricky out of the three laws. Newton's third law states that for every action, there's an equal and opposite reaction. Now, this means that if body A exerts a force on body B will exert an equal and opposite force on body A. You know when you push somebody, okay? When you push somebody, actually that person is also pushing you. Okay, I give you a very stupid example. Okay, there must be this friend, right, in your clique, right, that will do this one. You know, sometimes you're not aware, right? Then freaking random, they just go up to you, right? And then they smack you on the back. You're just gonna visualize, confirm about this person, right? You didn't even do shit to him, right? Or her. Then suddenly she just comes, then she slap your back. Wow, then you're like, wow, your back then pain, right? But the truth is that when that happens, when this is your back. Okay, so yeah. Oh my god, my drawing is so bad. Okay, this is you. Okay. And then when the person hand slap you on the back, okay, even though you feel the impact of the force, her hand also feel the pain. You get what I mean? Because when you slap her, when she slapped your back also slap her hand. That is Newton's third law. You know, the things that I really do not get in Hollywood cinema, right? Is, you know, like all the all the action star like Dwayne Johnson, right? He always hit butt, right, and smash, right? You know, so he uses his head to smash the enemy. But why does that not make sense in physics? It's because when you smash his head smashes the enemy is also smashing his head. So technically, hit butt as an offensive move doesn't make sense unless his skull is like freaking hard lah. But then again, it is Hollywood lah. Hey shit, I'm getting too many criticism for my drawing. I'm embarrassed. I already told you I fail my art and craft already. So please be kind to me, okay? All right. But just joking, it's fine. My drawing really sucks. Okay, but that's the point, okay? So Newton's third law, it just means that when you do something, there's always an equal and opposite reaction. Okay, now characteristics of your Newton's third law is that the force that is exerted is equal. It acts on two different bodies. It will be opposite in direction and it will be the same type of force. All right, now let's take a look at a question to see how it can be, how it will look like in a form of a question. It will look something like that. Now, I think what I'm trying to bring across here, right, is I want you to pay attention to the way the question is phrased. Take a look. 2,000 newtons of force is exerted on the water due to the propeller. Let me use another color. Due to the propeller. So propeller exerts force on water. So propeller on water. What do you think is the action-reaction pair here? The action-reaction pair should be water on propeller. Because if you're gonna exert a force on the water should exert an equal and opposite force on the propeller. So here we take a look at what the question is asking for. Can you see the phrasing? Force on the propeller due to the water. So here your water is exerting a force on the propeller. So how much would it be? It will obviously be equal and opposite. So the answer is just C. 2,000 propeller on water, 2,000 water on propeller. This resistive force here is not needed when we are considering the action-reaction pair. Okay, and because here the water is exerting a force on the propeller, the boat would move forward. That is the forward force. And we are talking about work done, that would be the force times the distance you have traveled. Ken? All right. Okay, Hilda has a very important question. Very, very good observation. When we say same type of force, what does it mean? Okay, I'm going to break it down as simple as I can. The two main types of forces is your contact force and what I'll call your non-contact force. Contact force, as you have learned earlier, your normal reaction force is 1. Meaning if I have a box on the ground, the box will exert a force on the ground will exert a normal reaction force on the box. The action-reaction pair here is between the box and the ground. Okay, so this is what we call contact force when the surfaces are actually touching. A non-contact force, on the other hand, is what I call a gravitational force. In other words, your weight. So who exerts the weight is not between the box and the ground anymore. If you're talking about a gravitational force, is between the box and Earth, which means here your action-reaction pair is between box and Earth. That means Earth exerts a gravitational force on the box will exert a gravitational force on Earth. Ken? So the type of force here, you're considering whether it's a gravitational force. In the future, as you learn static electricity, there's electric force, electrostatic force between unlike charges, or even magnetic force between unlike poles. So the type of force there can be categorized under contact and non-contact, but electric, magnetic, or gravitational force, these are all different types of forces. Okay, would there be a case where the values are different for the question? Yes, it can be different. Okay, normal contact force is literally like if you are standing up, you exert a force on the ground, right? The ground exerts an equal and opposite force on you. Which is why if you're standing on a piece of paper, the paper will break because the paper cannot exert an equal and opposite force to support the force you're exerting on it. You kind of get the idea? So it will actually break through. Or you cannot stand on styrofoam because styrofoam is not strong enough. It cannot exert an equal and opposite reaction force to keep you there. Okay? Wouldn't the force cancel out? Yes, it will cancel out, which is why your object with equal forces that cancel out would remain stationary, or it will remain in a state of motion. Okay, so correct, that's resultant force. Okay, to finish up, right, let's quickly talk about friction. I don't want to talk too much about it because you guys already know how friction works. There's useful, friction as a nuisance, how to reduce friction. These are pretty basic stuff. The one I like to focus more on is here, this one. Now, this one is going to get a bit confusing, so please pay close attention here. Now, if I'm trying to walk towards the right side, okay, you might first initially think that friction is supposed to oppose the motion, right? So you might think that friction will be towards the left side, right? You might think that that's the case. But please understand that normally what happens is that you're actually generating friction in the same direction as your movement. Now, let me try to simplify this for you. If I'm walking towards the right side, can you visualize the shoe is actually sliding backwards? Right. So when your shoe is sliding backwards when you're walking forward, the shoe is going this way, your friction will be in the opposite direction between the sole of the shoe and the ground. So did friction oppose the motion? Yes, it opposed the motion of the shoe that was sliding backwards. However, overall, what you will always notice is that if you're planning to move forward, friction is usually in the same direction as the person or the object's movement. Of course, if you're walking backwards, everything just reverses, meaning your direction change, your friction will still be in the same direction as you moonwalking backwards. But now your shoe is sliding forward instead. It's the same thing if it's a car wheel. If my car is going this way, visualize how your wheel is turning this way. When the wheel is in contact with the ground, can you see the wheels sliding backwards? Friction generated will be forward. The point I'm trying to make here is that if my car is moving towards the right, my friction should be in the same direction as well. A bit counterintuitive, right? You might think that, oh, friction opposed, but no, you need to think about how the wheel or the shoe interact with the ground. Okay, is it true that it always opposes the relative motion? Answer is yes. But you need to remember for a person or for a vehicle moving forward, the shoe or the wheel is actually sliding backwards. Which brings us to this question inside your revision package. This is from the TYS. Now let's try to figure out why the answer is B. This one I feel, even if I give you the answer, right, you might not know how to solve it. Okay, I give you all maybe 1 minute to think about it. I give you the answer already. You see if you can figure out why. Those a little bit more adventurous one, right? Just type your answer in the chat. You can PM me or chat. Why you think answer is B? Using what concept to explain? I think that's what I'm trying to drive at. Okay, then for those who are still like racking your brain, go and think about it. Oh, I see good responses. There are 2 different concepts that are required here. Y'all see if y'all can hit it on the nail. I'll tell you later on, but I want you to go and think. 2 concepts. You need 2 things that we have discussed in this chapter to solve a question like this. Good, good. Okay, let's start. The first one, force on the man's hand. I'm gonna isolate to just this area here. The man is pushing the box. The way to solve this is Newton's third law. Remember? A on B, B on A. If the man is exerting a force on the box, the box will exert an equal and opposite force on the man's hand. You get it? The man is pushing the box to the right, ma? So the box is actually pushing the man towards the left. So to solve the hand one is about Newton's third law. Okay? Next, how does the man move towards the right side? The shoe here is actually sliding backwards. Remember, we say that when he's trying to move forward, his feet is actually sliding backwards. This will generate a friction in the same direction as where the man is moving towards. The one that we just talked about. Man is going to the right, friction generated with the ground would be in the same direction, which is why force on the man's feet is towards the right. So what are the two concepts that are required here? You need to remember Newton's third law as well as friction. Okay? So these are the two things you need to solve this question. O-level question. Wow, you guys are ready for O-levels. Amazing. Okay, one final question before we head off for our break. Okay, so this question is yet another one on getting you all to remember the importance of not F equals to MA. Say it with me. RF equals to MA. Now, what is resultant force here? Resultant force, yes, we take mass times acceleration. We find out that our resultant force is actually 1,600. Now, the car engine exerts a driving force of 2,500. It's like, the value tak match, like different. Why? Because how do we find resultant force? For car, shit lah, my car damn ugly. I'm exposing my drawing skills too much today. There will be resistive forces, either in the form of friction or air resistance. Doesn't really matter. But the car will be slowing down. The driving force is exerted by the engine pushing the car forward. The main thing I need you to understand here is that when you take driving force, minusing away resistive forces, you get your resultant force. In this question, you managed to find what the resultant force is. You also was given the driving force. You just need to rearrange the formula to figure out how much is your resistive force. That will get you your answer. All right. So in order to avoid all sorts of confusion you might have, there's only one formula that is central to this chapter, which is RF equals to MA. Resistive forces could be anything that includes friction or even air resistance. Anything that opposes your motion is considered a resistive force. Okay, it acts in the opposite direction to your driving force. Ken? All right, so that's all for now. Right now, the time is around 6:02. I'll play two songs, so around 6-minute break. When we come back, we're going to work on moments as well as work energy power. All right, so you can go for a short toilet break first. And then when we come back, we'll finish up the last two as well as the giveaway. All right, so stay till the end. You stand a chance to win the curated notes. So please do not log off yet. Okay, for those who need the QR code, it's here. So you can scan to download a soft copy of this. But let's take a short break now. We'll resume in 5 minutes. Okay, I'm going to look through the questions. Then I see which ones I can answer. I'll try my best to answer them. Let me stop the music. Okay, come, let's see. Okay, there seems to be still a lot of confusion over the Ferris wheel one. So let's go back to it. So the Ferris wheel one, I wasn't claiming that the velocity will increase. I merely stated that because the direction is changing, your velocity will be changing. Okay? So the idea here is that the magnitude is not changing, but the direction here is changing. Okay? So as long as your direction is changing, your object will undergo a change in velocity, which means it's undergoing acceleration. Okay, so we are not talking about the acceleration changing, but simply the spoke is undergoing acceleration. Okay, we're not talking about the magnitude of the acceleration here. We're dealing with the direction aspect of it. Okay. Is friction a resistive force? Yes, definitely. Can? Now, I don't want you all to be confused with this. The whole purpose of me bringing up this question, right, there's only one goal, which is for you to remember what a vector quantity is, that there's both magnitude and direction. The purpose of this question is to get you to understand something at constant magnitude can still be undergoing a change in direction, which means that your velocity can still be changing. This is not meant to be a quantitative calculation question. Okay, so if you are thinking too hard on how to calculate this, no, that's not the point. The point is more on a conceptual one on how the direction is changing. Okay, but magnitude stays the same. Okay, so we are not calculating the acceleration. We are merely stating that it's undergoing acceleration. That's all. Okay, if not, let's push on. We're gonna talk about moments next. Oh, my favorite. Okay, y'all ready? I think most of you should be back, right? If you're back, can you just give me a thumbs up? So if majority is back, I'm gonna get started. Okay, I see around 38, 30. Okay, whatever, I'm just gonna get started. Lol. Okay, let's go. So let's set the timeline first. We'll go through moments. Once we are done with moments, we'll go through work energy power. Then we'll come to around 6:45. Then we'll do the Kahoot giveaway. Okay, so last second half, let's tune in and let's go for it. Okay, moments, I'm not going to talk about the basic stuff. The basic stuff includes how to calculate moment, right? Force times distance. This one, I expect you all to kind of know how it works already at this point. Now, what else do you all need to know? Principle of moment states that when an object is at equilibrium, sum of clockwise, take note, a lot of people miss this out, about any pivot is equal to the sum of anti-clockwise moment about the same pivot. A lot of people, when they are writing out principle of moments, they fail to mention the word pivot. Just remember, if you're going to talk about moments, right, moments is definitely about a pivot. So you must include the word pivot in your explanation or your answer. Okay, now for something to be in equilibrium, two conditions needs to be fulfilled. Firstly, resultant force must be zero. Secondly, your resultant moments must be zero. Resultant moments is literally anti-clockwise, must be equals to clockwise. RF is the one that we have learned earlier. Your overall resultant force must all cancel out one another for something to be considered in equilibrium. Now, more importantly, is the questions that you'll get. So for this one here, I'm not going to spend too long on the theory. Let's try actual questions and solve them. Now, the basic question that you're going to get, right, is when there's only one pivot. This one's super simple. You just take F times D, F times D. This one's easy peasy. This one we'll try, but it's not very complicated. Now, second scenario that is more complicated is when there is no established pivot, aka there's more than one pivot. Now, let's take a moment to look at this question together. This is very important. So here, 20 kg, first instinct is you say, change it to 200 Newton, right? Because kg is mass, Newton is force. So we want forces. So we have one force here, downwards. We have another 100 Newton, which is the weight of the rod itself. And we have point A and point B. Now, the question is asking us to determine the tension in A and the tension in B. Then the first thing you might be thinking of, watcher, there's no pivot. How? The worst thing you can do here is you assume the pivot to be in the middle. No, I emphasize again, it will never be just in the middle like that. If they do not give you a pivot, doesn't mean you anyhow go and draw in a pivot. The pivot in this question will be at either points of the suspension. Meaning, you can let the pivot be at A, or you can let the pivot be at B. Either point A or point B will be the pivot. Let's go with the assumption that we're going to use A as the pivot. All right, now let's focus on tension in A first. Would tension in A give me any clockwise or anti-clockwise moment? Answer is no, because this A passes through the pivot. Perpendicular distance here is 0. So when you let the pivot be at A, tension in A will not be included in clockwise, anti-clockwise. because it has 0 moments generated. Clear? So when pivot is at A, tension in A, we do not account for it in clockwise and anti-clockwise. Now let's move on. 200 Newton. Pivot is on its left side. This way, can you all visualize it's going this way? For this two? This is clockwise, right? So here, what you would look at, this 200 Newton, this is clockwise. This is clockwise. And here, the tension in B, can you all see is going this way? The pivot is here, right? So tension in B is actually anti-clockwise. And now, can we actually start solving? Of course. Because what you want to do here is to take the sum of the clockwise times the sum of plus equals to the sum of anti-clockwise. So you take a look at my working here. I take 100 newtons times 1 meter, perpendicular distance, right? Times the 200 Newton times perpendicular distance of 0.5. This here on the left side gives me my clockwise. My clockwise must be equal to my anti-clockwise. So how do I do this? Tension in B, which is my only anti-clockwise, times the full perpendicular distance of 2 meters. I have solved for the tension of B. Okay? Now, the question wants the tension in both the strings. So once you're done solving tension in B, we'll bring our attention to solving tension in A. Now, one way you can solve it is definitely by now letting the pivot be at B. Then suddenly tension in D is no longer part of clockwise, anti-clockwise. You repeat the whole process again, similar to what we have done just now. However, there's a shortcut here, which is that you do not need to do clockwise equals to anti-clockwise. Why? Because earlier in this scenario, we mentioned how when an object is in equilibrium, your resultant force must be 0. So if your resultant force must be 0, your sum of upward will be equals to the sum of your downward force. Observe how TA and TB, they are both pulling it upwards. While my 200 Newton and 100 Newton is pulling it downwards. So that's why my sum of my downward force is 200 plus 100. Given that we already found that TB is 100 Newton, we can then solve for TA. TA would be 200 Newton. Even if you take moments about B, you would find the same answer itself. So if you're a smart student, you would know that this question will be a 3-mark question. Because the first half to find tension in B is 2 marks. To find tension in A is only 1 mark. Right? Why? Because this is simply a sum of upward equals to sum of downward kind of question. That will get you your final answer. Clear? Right. So this one is not very extensively taught in school. If your teacher good enough, they might mention this, but most of the time the teacher might just gloss over this. So what I'm worried about is that if a question comes up where there is no established pivot, are you still able to solve it? So that's something that I wanted to address today. Now, instead of talking too much here, let's try some questions. Okay, I'm going to skip this one on the stability first. Let's try question 16 first. Can? All right, I'll just give you maybe a minute to try do your calculation. Then, of course, I'll be talking about this and the working itself. Pivot is here. Do you know how to solve this? Okay, let's take a look. When you're doing this question, you find that the pivot, they already say it's on the shoulder, right? Here, this is a 24 newtons. Is this clockwise or anti-clockwise? This way, right? Pivot is here. This is anti-clockwise. Then what about this F? This F is this way. This F is clockwise. So all you need to do is to take anti-clockwise equals to clockwise. F times D equals to unknown F times t. How much is the F here? Hey, shit, I need my calculator. My mental sum not good enough. 12 divided by 0.3, 40. Okay, so we figured that this F here is 40 Newton. To finish solving the question, is the answer just 40? No, you just need to remember, these two are down and down. The shoulder is up. Sum of upward equals to sum of downward force. So how much is the sum of upward? There's only one, right? You take 24 plus 40. Total upward force is 64. So you might want to write this down. Upward equals to downward force. So your upward force on the shoulder here, F, is the sum of the 24 Newton plus my 40 Newton. 64 Newton. Okay, how do you know whether it's clockwise or anti-clockwise? Fair. I'm going to teach you a simple trick that I usually teach my students, which is this is the pivot, right? So this is like the middle of your clock. Imagine this to be a clock. 12 o'clock, 3 o'clock, 6 o'clock, 9 o'clock. Right now, your minute arm is here. Your minute arm is going this way. Can see? 9 to 6. Clock or anti-clockwise? Anti-clockwise, right? Because you're moving your arm of the clock from 9 to 6 o'clock. Next, if this one here is going down, right now it's pointing at what time? It's pointing at 3 o'clock, right? And it goes down. This is clockwise. Okay? So you just visualize there's a clock there. Then you see whether it's going this way, what time to what time. Okay, that's all. Okay, so if it works for you, great. But I'm just going to leave it without the clock itself. Can I? Let's try one more question. Question 5. Okay, same thing. I'll just give you maybe a quick 1 minute to work on it. Then, of course, I'll be going through after. How y'all can follow or not? I'm very scared that I choose the question too difficult. But I don't want to choose too easy as well. If not, no point. Okay, let's start. So here, when you see the term uniform meter rule, uniform indicates that your weight is found in the center. So given that what we have here is a meter rule, right? It means that where would the weight be found? The weight would be found exactly at the 30 cm mark. Okay. So what happens here is that we have a mass of 500 gram. 500 gram weight. How do I turn weight? How do I get weight from mass? I need to take mass times gravity, right? But here, please remember, 500 gram. SI unit for mass is kg. So you want to write 0.5 kg times 10. That gives you 5 Newton. Okay, so the weight here is 5 Newton. Okay, so they're asking for the downward force at X to balance the ruler horizontally. So actually, after this point is a very simple case of clockwise equals to anti-clockwise. This is anti-clockwise. Your weight here is clockwise. So all you need to do here is to write out the equation. Anti-clockwise would be your force at X. I just write F lah. Too many working. F times 20 cm. Here, clockwise is 5 Newton times 30 cm. All right. So after that, when you go and calculate and solve for F, F here should be a 7.5 Newton. Ta-da! Now, a few things I like to address. Some of you might be like, just now you convert the SI unit to Newton. Shouldn't we convert this 20 cm and this 30 cm to 0.2 meter and 0.3 meter? The answer is that you can, but does it really matter? It doesn't matter, because at the end of the day, 20, 30 and 0.2 to 0.3, we are comparing effectively a ratio here. It's a 2:3 ratio. So as long as both the units are the same, that's all we need. We don't need it to be equal. Like, we don't need it to be SI unit specifically, as long as the units are the same. Okay? But for mass, right, mass conversion to weight needs to be in its SI unit. Okay? So I hope you are not too confused here. If you are very confused, right, just change everything to SI unit. Okay? But if you know what I'm talking about, you're just effectively comparing a ratio, you can leave it as 20 and 30. Okay, the 30 cm is because a uniform meter rule means the weight is found right in the middle. A meter ruler is 1 meter. Half of the ruler in the middle is at the 50 cm mark. That's how I got the 20 and 30 here. Can? Okay, we're going to try one more question on moments. This one is probably the most challenging one, because you're going to get really confused with the clockwise and anti-clockwise here. So I'm just going to same thing, give you a quick 30 seconds to look through. Then I'll teach you exactly step by step how we're going to go through this. Okay, let's take a look at how many forces do we have. Identify them straight away. There's this one, and this one. 3 different forces. So this is what I like to do when I get my question. I identify the 3 forces. The next thing I would love to do is to identify whether it is clockwise or anti-clockwise. But before we get there, right, we need to establish the perpendicular distance as well. Now, what I tend to do is I like to draw and use a ruler to extend my line. So this is my 15 Newton, right? You see where the pivot is? You want to be able to find the perpendicular distance first. And how much is my perpendicular distance here? 3, 1, whole thing here is 4 meter, 2 meter. This is 2 meter. So I know that for my 15 Newton to the pivot itself, that is 2 meters in length. So later when I do my 15, it will be times 2. Let's try for the second one. Same idea. We extend the line of action of the force, and then we figure out what the perpendicular distance is. This one here is 3 meters. Can you see? 3 meters. Now, the last one, which is the one that's horizontal, what you want to do is the same thing, draw a line across. Right. You want to see here the perpendicular distance is 2 meters. Now, let's identify whether they are clockwise or anti-clockwise. This one here, can you all visualize the clock? This is 3 o'clock to 12 o'clock. The thing is going this way. This is anti-clockwise. Okay, so I'll write down an anti-clockwise beside this red line. The blue one definitely is in the opposite direction, so clockwise. The most difficult one is probably the one in gray here. Is this clockwise or anti-clockwise? Right now at this position is 6 o'clock, right? It's going towards 3 o'clock. You can see it's pushing this way. So this is actually technically a anti-clockwise. So once you get that, you can calculate how much is the clockwise and how much is the anti-clockwise. Anti-clockwise is 15 times 2. This is the red one. Actually, maybe I'll just do it in a different color so it's a bit easier to see. So yeah, 15 times 2. Okay, anti-clockwise. The other anti-clockwise that you want to be adding in is the 10 times 2. Force times perpendicular distance. Meanwhile, your clockwise is actually the only one which is in blue, which is your 15 times 3. So let's calculate what is the total sum here. The top one, you'll get 50 Newton meter. The bottom one, you'll get 45 Newton meter. So you have 5 more Newton meter of anti-clockwise. So the resultant moment here is 5 Newton in the anti-clockwise direction. Okay, for the previous question, the 30 cm one I already mentioned is because your meter ruler is halfway mark is the 50 cm mark. So if this is 20 cm, this is 30 cm. Okay. How is the 10 Newton anti-clockwise? I think what you want to visualize here is that the rod is going towards this direction. It's going towards 6 to 3 o'clock. So if you really exerted a force here, right, it's going to push this whole thing this way. You need to visualize it a little. So that's why I say 6 to 3 anti-clockwise. Okay, then I'd like to wrap up this chapter by talking about two other things. Center of gravity, take note of the definition here. It is the point through which the entire weight appears to act on. It might not necessarily be at that point, but it's the point in which it appears to act on. Hint, hint, might come out later for your Kahoot. So center of gravity is defined at the point through which the entire weight of the object appears to act on. Okay, or seems to act on is fine as well. And there's exactly three types of stability: stable, unstable, neutral. Without complicating it, right? Stable means if I push it a bit, it will return back to its original position. Stable. Okay. Unstable means that I push it a bit, the whole thing will collapse, like your Jenga tower, right? You push it a bit, the whole thing collapses. That is an unstable equilibrium. Neutral equilibrium means when I push it, it will stay in its new position. The easiest example is imagine a soccer ball, right? You go and push the soccer ball will roll, right? But it will roll to its new position and it stays there. Did the soccer ball topple? It didn't, right? It just stayed at the new position. So that is typically what we call a neutral equilibrium. And there's only two factors that affects your stability. If you want something to be more stable, you increase your base area, you lower the center of gravity. Okay, that's about it. So the question that we see here, we got 4 ball, right? Which one is what stability? Can you see that A, if I push it a bit, what will happen? It will freaking drop, right? So this is what we call a unstable equilibrium. B is the exact same thing. If I push it a bit, it will topple. So unstable. C is considered stable. Why? Because even if I try and push it, it will return back to its original position. So that is why we call it stable. And D, if I push it, it will stay at its new position. Okay, which is why we consider it a neutral equilibrium. So whether it will return back to the original position depends on whether the center of gravity falls outside the base area or not. So let's say right now I have ... This is my base area and my center of gravity is somewhere here. If I displace it, maybe my center of gravity shifts to this position, but it's not yet outside the base area, meaning it will not topple. But if my base area is very small and my center of gravity is here, when I push it this way, my center of gravity is now outside my base area. Now I'll generate a moment, force times perpendicular distance, that will cause this whole thing to topple. So the main determining factor is whether your center of gravity is within or outside of your base area. The moment it falls outside your base area, topple. But if it's within, it will still revert back to its original position. Okay, so that's about it for this chapter, which means we are left with our final chapter, work, energy, power. Okay, if your center of gravity is directly on the pivot itself, the object is in equilibrium. That means it's fine. That means it's considered stable. Okay, now for energy, let's touch on mainly the important ones. You should know these are the two key formulas you will need. Ke is half mv squared. Your gravitational potential energy is calculated using mgh. Unfortunately, there's another principle here. Principle of conservation of energy states that energy cannot be created or destroyed. It can only change from one form to another, but the total amount remains constant. For those of you who actually have a copy of the curated notes or are planning to get one, just take note, whatever is bolded is keywords, meaning it must appear in your answer. Okay, so principle of conservation of energy is not a very complex concept. It means that energy will never disappear. It's either converting from GPE to KE or from KE back to GPE. And in most cases, because friction exists, there can be work done against friction as well. Now, one of the main concepts that you will be confused about is the idea of work done. Now, work done is actually calculated by taking force times distance. But this distance must be in the direction of the force. This is very important. So Earlier, when we are doing moments, it's also F times D, right? But it's force times perpendicular distance. Work done here is force times distance in the direction of the force. Let's take a look at this case study. My goal is to move my box from point A to point B. I want to move it up the slope. But when I move it up the slope, right, there are two things that needs to happen. Number one, I need to overcome the friction. So work done against friction. My friction is 3 newtons. My box is moving up the slope, which is 5 meters in length. So when I take F times D, that is 15 joules. On top of that, as my box moves from point A to point B, it would have gained GPE. So my box goes up a vertical height of 3 meters. So when I do MGH, my gain in GPE is 30 joules. How do I overcome friction and how do I gain GP? It did not happen from nowhere. Energy was not created here. So somebody had to get the work done. They had to give and exert a total amount of 45 joules to move it from point A to point B. Out of the 45 joules, 15 joules is used to overcome friction. 30 joules was converted to gain in GP. Okay, so I know when we say work done, you always think, oh, F times D, F times D. The truth is that work done can either be F times D, it can also be gain in energy. Gain in energy is also work done. Here's the magic trick. Work done, you take a look at the units. Is joules. Surprise, surprise, energy unit is also in joules. In other words, both energy and work done, they are the same thing. Gaining in energy is literally work done. So why is this chapter called Work, Energy, Power? It's because work and energy is literally the same thing. So don't get confused when you see that, hey, GPE, isn't it energy? Isn't work done something different? No, work done is energy. A good way to think of this is your energy input helps you get the work done. So actually, they are just the same thing, right? To put it simply. Okay, so work done and energy is the same. Of course, since you're taking pure, you need to know power. Is work done over time? Or, no surprise, right? Energy over time. It's the same thing because work done and energy, same. Efficiency, useful over total output. All right, now let's take a look at some questions. This one is a lot easier. So here we see a flight of stairs, right? The question is asking how much useful work is done. Now, what's the purpose of climbing your stairs? Is to go upstairs, right? Literally. So the distance you are concerned with here is not the 5, not the 4, but the 3 meters. Another clue is that when you are saying the weight is 600 Newton, weight is always acting downwards. So here your force is acting downwards, or more of what I say vertically. So when you're calculating and choosing which weight to be using here, right, you should definitely be choosing the one that is vertical. All right. So at the end of the day, all you need to do is to take 600 times 3, F times D, that is your work done. So don't use the 5 and the 4. In almost no scenario, you'll use the 4. 5 is more for if there is friction. Okay. Now, question 10 is a more difficult variant of what we have just gone through. Now, remember, right, when it's going up the slope, okay, there are a few things, right? There's frictional force, 8 Newton. Just do ourselves a favor here and just draw it out. So first thing we can calculate is work done against friction. And how do we calculate that? F times D, right? How much is our friction? 8 newtons. And over how long? The box moved from X to Y. It went up the slope by 9 meters. So times 9 meters, 8 times 9, 72 joules. Right, work done Newton meter, work done joules, same thing. Now, for me to go up from X to Y, there was also a gain in GPE. So how much is my gain in GPE? MGH, right? 2 kg, gravity is always a value of 10. The vertical height that I went up by was 5 meters. So 100 joules. So what's my total work done? My total work done is 100 joules plus 72 joules. In order for me to move it from X to Y, I overcome friction, I increase the GPE, my total work done is 172 joules. And finally, to calculate power equals to work done over time, 172 over 4 seconds. Answer is 43 watts. It's like, shit, my mind is blown. Okay, keep it simple. You go up the slope, two things you need to do. Overcome friction to go up, and you gain in GP. GP did not come from nowhere, it is work done. Okay, so as you go up, the slope, total work done is 172 because you are taking the 72 plus the 100. Useful work done really depends on the situation. For this particular situation, you can argue that the useful work done is the gain in GPE. Because work done against friction is not useful. In a sense, we can do without it. Something like that. So useful work done depends on the scenario. Okay. So cannot give you a very specific work here. So in this scenario, work done total is 172, but your useful work done was probably just 100 joules. Okay, if not, I'm going to move on to the next question. I want to do question 9 first, then I'll go back to the previous question. So let's take a look at this question itself. Our Lazada delivery man, 60 kg, walks out with a box of 25 kg. Wow, so heavy. Okay, so total mass here is 85 kg. This guy, poor thing, don't know why he don't want to take the lift. Go and climb the staircase. 30 meters, staircase, 2 minutes. So what is the power produced by the delivery man? Power, remember, is work done over time. How much is your work done here? Mass is how much? 85 kg, right? But this is mass. Weight, W equals to mg, 85 times 10, 850 Newton. So your F times D here is 850 Newton times your vertical height of 30 meters. What is the time? 2. Really? This is the second thing I want you all to remember. When you're dealing with time, please don't be the blur sotong to write 2 minutes. SI unit for time is always in seconds. So you want the times 60 seconds. Okay, that will comfortably get you to 13 watts. Alternatively, if you're not a big fan of work done, you can also do it equals to energy over time. The energy here would be your GPE over time. But what you'll be surprised to find out is that if you do your MGH over your time, the value that you get is exactly the same. 85 times 10, the height is 30 meters over 2 times 60 seconds. You still get 213 watts. My point here is simple. The answer will be the same, right? Because work done and energy is the same thing. So whether you do it in terms of force times distance, or in this case, if you prefer to do it in terms of GPE, gain in GPE, 85 kg went up a height of 30 meters. Sure. But the point is that you will still get the same answer. Okay, so I hope you all don't ever get confused between work done and energy because they are literally the same thing. Can? Okay, if not, one final question before we call it a day for the content portion. This question. Now, this is probably one of the most difficult questions. I don't just want you to learn how to do this question, but I want you to learn exactly how to avoid making the mistakes that most of your friends are gonna make. Okay, this is how it's gonna work. The child at the top of the slope, okay, mass is 30 kg. She has an initial speed of 0.6 meters per second. At the bottom of the slope, she turned and she has 7 meters per second. Okay, what is the height of the slope? Now, you need to know here her gain in KE is equivalent to her loss in GPE, right? Because how did her speed increase? It's because GPE was converted to KE. So with that, right, the priority comes into, to find the height, I would first need to find the gain in KE. You know what most people would do? Most people will remember, okay, KE, okay, what, half MV squared lah, who don't know, right? Then they'll start looking at the question. Oh, 7. Oh, 0.65. Then you know what they'll do? They'll take 7 minus 0.65 because that's how much the KE has changed. Then what they'll do is they do half MV squared. They find the gain in KE to be 604.8. Now, if I let you do by yourself, I think a good percentage of you will be doing this. But I need you to understand that this is wrong. The correct way to calculate gain in KE is not to take 7 minus 0.65, but instead, you want to find at the top of the slope what is the person's initial KE. And as he slides to the bottom, what is the final KE? So when you take initial and the final, then you can find the loss in the KE. Now, here what you're doing is you're doing half MV squared minus half MV squared. Take note, this is different from 7 minus 0.65 squared. For those who are a bit better at math, right, this working is equivalent to saying you are taking A minus B squared. While this working here is A squared minus B squared. It's different, right? So you cannot take 7 minus 0.65 directly. That is not correct. So when you actually go and calculate initial and final KE, take final minus initial, you get your gain in KE. Then MGH is your GPE. You know the mass is 30, G is always 10. You can actually figure out what's the height of the slope. Okay, so if you do the wrong working, right, you actually end up with a completely different answer. Probably you'll get a different answer. So make sure that when you're calculating this, remember half MV squared minus half MV squared. Okay, I think this is a bit of a typo, sorry. Maybe this value should go here. Sorry. Can Okay, so I'll go and update this later on, but just take note that your answer here, if I'm not wrong, quite confidently, it should be B. B should be correct. Thanks for pointing that out. All right. Any further questions before I wrap up the content portion? Was it intense? I try to keep it as light as possible already. This is like the tip of the iceberg. All right. Question 9, why is 25 kg included? Oh, because the delivery man has to not only move himself, he has to move the mass of the object as well. So you need to add up the total mass, not just the mass of the delivery man. Right? It's the same thing as you're going to the gym, right? You put on more weight, the power you need to generate to lift the weight is more. So you need more energy and more work done for that. The motion is both the delivery man and the box is going up the stairs. So both are moving upwards, the vertical height of 30 meters. Okay. If you memorize the curated notes, is it enough? I never am an advocate of memorizing. I think physics, especially when it comes to physics, is about application, which is why today you see I didn't talk much about content. I really focus more on application of the content. So memorizing might get you a D4, right? But I'm sure if you are here and you're enthusiastic about learning, you're probably aiming for A1. And I think it's really about understanding your content and then applying it. That would be the big step forward. Okay, now before I head over to the Kahoot, right, I need to share with you guys some of the key details for the upcoming signups and stuff. So we are actually opening up group tuitions for 2023. So for yourself, if right now you're in Sec 3 and you're moving into Sec 4 and you're considering getting tuition, this is our intake period. For myself, I usually teach around 4 pure physics classes. Each class you can estimate around 10 people. So I need technically have around 40 slots per year for physics kids. So few questions. You can ask me any questions you want here. For myself, I'm mainly teaching at the Toa Payoh, Hougang, and potentially the Jurong East outlet. For me, there's availability for both weekday and weekend slots, but I only teach pure chem and pure physics. Now, few of the things that I want you all to take note of is that if you're already considering to get tuition, I think it's important for you to understand the best deal you can get at the different points. Okay. Now, for those who, after today, you're like, watcher, I like the way you teach. I learn physics from you. Sure. And if you already decided on that, it is much better for you to take the early bird package. Now, what is inside the early bird package? Number one, right? You sign up for physics, right? You can get 3 subjects notes. So physics confirm you need to take a lot because you're taking physics, right? But then you can take, for example, if you want to take my chemistry notes, you want to take e-math notes also can. So you actually get 2 other subjects notes for free if you sign up before 30th September. On top of that, once you sign up, I'll be reaching out to you to confirm the class timing and the time slot that you want. Normally, my weekend slots fill up super fast, but if you sign up early, you'll get access to the better timings, maybe probably your weekday nights and your weekends itself. And I'll also give you this thing called the end of year exam kit. This end of year exam kit, I only give to my own students. So this kit is a lot more detailed with a lot more content up to the chapter of sound. Okay, so you'll see that there's a lot more stuff for this, but this is not the free one. This is the one that I actually prepare for my own students. So if you sign up now, then I'll give you the end of year exam kit so that you can prepare for your EOY. So this is only for students that sign up for tuition before 30th September. Okay, so all of this early bird special and stuff, they apply for all of the subjects. So it's not just physics or chem. Okay, so if you take math, for example, you can take the science notes as well. Now, if you're still a little uncertain whether you want to join the tuition or not, because you don't know how it's going to go, you can opt for the trial package. How the trial package works is super simple. You sign up trial, right? Sign up with your friend so you can come together. The session is entirely free, so you don't have to pay a single cent. I will be conducting the free trial lesson at the location in which you choose. We will go through a lesson as though it is an actual tuition session itself. So you'll see how I go through the content, you'll see the worksheets and the materials you'll be getting. And then after the session, you can then make your decision whether you want to join or not. So if you join the trial package and then you sign up after, you actually get 2 sets of curated notes, meaning you probably can take physics and 1 other subject. So obviously the early bird is slightly better, but for those of you who are not very certain on whether you will like the lesson or not, definitely the trial package would work. Now, for some of you who are considering, maybe I only want to take next year, I think that is fine as well. But if you join anytime in 2023, then there is no more offer. So there's only like 1 subject, which is the subject you sign up for. And most of the time, the slots available is a lot less. So for myself, most of my classes fill up by January. Like usually by then, I cannot take in more students already. So maybe other tutors, but most of the time, the best slots are all filled up. So if you want to sign up with me, I suggest you do it early. But of course, you should discuss with your parents first. And if you have friends that want to join together, usually it's a bit more fun to come together. Okay, so I hope it's clear what package you can sign up under. When you go to the website and you sign up, there's the option to click which package you want. Okay, if you have any questions, you can just text me at my number. So the contact number below is my number itself. So you can text me, WhatsApp me, Telegram me, whatever. Then I'll answer to any of your queries. Okay, now, few things to take note of is that if you join, right, it is not necessary for you to turn up for lesson every week. We actually offer what we call a hybrid lesson, meaning you can choose to attend physically, like you can see me in real life. Sometimes I will buy bubble tea, but not too much. If not, I'll get diabetes because I got like 10 to 12 classes. But you can also choose to attend online if your schedule does not allow. And let's say during that week, you got CCA competition or anything, I actually have other classes in the same week that you can join as well. So you can do makeup lessons with the other class. You can probably tune in online and stuff. The content would largely still be the same because every class will be going through the same stuff. Okay, so don't worry if your schedule is a little bit packed. There's usually a lot of flexibility for that. Okay, so I hope that it is clear now in terms of the details of it, which means, drum roll, we're going to move into the giveaway. So I emphasize on a few things first before I carry on. How many locations are we located at? 4. So we have our upcoming new center at Bukit Timah. We are with partnership with our spaces at Toa Payoh, Hougang, and Jurong East. All of the locations are like 3 to 4 minute walk away from the MRT. So it's like super near. I teach chem and physics, and these are the deals for the packages. Okay, pay attention because later the Kahoot will need. Okay, now before I jump over to the Kahoot itself, can I just request that if you are Sec 4, you're Sec 4 and you're tuning in, it's cool, I'm okay with it. But as we are going through the Kahoot, can I request you just let the Sec 3s play? Meaning, I want this giveaway, the winner, to be a Sec 3, right? Because this session is meant for the Sec 3. Sec 4 play a bit unfair because y'all probably can solve everything a bit like faster. So you probably have a better score. All right. So let's keep this strictly for the Sec 3s. All right. So let's go. Y'all can see the screen, right? Okay, in case you have never played Kahoot before ever in your life, you just need to go onto your browser, type in kahoot.it, type in the game pin, and join. Winner walks away with a copy of the curated notes for physics. So go find it out, guys. Okay, I'll give it one more minute for those who are struggling to join. Okay, anyway, I know some of you already pre-signed up for tuition with me. I'll be texting you soon. I see a couple of you in this session as well. So you have priority in terms of selecting the slots as per any other of the early birds. So, okay. Then once you sign up, I'll send you the end of year revision kit straight away. Oh, exciting. How do you want to put the emotes, yeah? Okay, 30 more seconds for whoever is still joining. How exciting. Anybody want to change your names? Okay, I remember, let the Sec 3s play. Sec 4s, please don't join. Okay, starting in 3, 2, any more? Anybody panicking? I start already, Wow, wrong, just in time. Okay, sorry, I'm gonna start, Let's go. Okay, before I go on, just take note, the questions are not purely physics questions, okay? It will be inclusive of things that if you paid attention to the details of the sharing earlier, you'll stand a better chance at winning. Okay, so only the winner will walk away with a set of curated notes. Let's go. What year did I start tutoring? This one I shared at the start of the lesson, but very hard to remember. Not bad. Actually, a lot of you actually knew 9 years. Next year is my 10-year anniversary. Wow, look at me. Oh my god, I didn't think I'll be teaching for so long. But hey, it's quite fun. Let's see who's in the lead. Okay, very close, very close. First question only. This one easy. Vector quantities only, Okay, please do not select the option that has scalar. I just want the vector quantities only. Y'all know y'all click faster, more points, For those who are a bit like wondering how the whole Kahoot works. Okay, for those who are thinking energy is a scalar quantity, energy has no direction, people. Okay, let's move on. Where are the group tuitions locations at? 4 locations, right? But where are the 4? And to share, we're probably opening up our second center next year, early next year. So actually, we will move some of the group tuition to the new center. All right, Le Xuan doing very well, Newton's third law. Is this true or false? For every action, there's an equal opposite reaction. You go and slap your friend's back. Your friend back will slap your head. Whatever. When you headbutt somebody, somebody else will headbutt you. It's true, guys. Newton's third law, equal and opposite. Which other subject do I teach other than physics? Actually, I used to teach more, but then after a while, I just decided. Okay, yes, chemistry. Okay. Me love some chem and physics, man. So if you take chemistry with overmark, it will be still with me. So you'll see my face a lot. Okay, so you're supposed to arrange it in terms of how you will explain terminal velocity as if it is a structured question. Okay, arrange in a correct sequence. Why is the music so simple? Yes, yeah, why the music so suspenseful? And this is probably the hardest question already. Object in free fall, air resistance will increase as velocity increase. Eventually, air resistance equals to the weight. That's when your resultant force is zero. No acceleration, moving at constant velocity, known as terminal velocity. Oh no, Lexin is being dethroned. Ying Square is in the lead now. Let's go. What are the perks of the trial package? Meaning you want to come for a trial lesson first, and if you sign up, what do you still get? And when is the trial? November or December? Question mark, question mark. Yes, so if you sign up for the free trial, you can just come, it's free. And if you sign up, you actually still get 2 sets of curated notes, okay? Ying is still in the lead. Will she be able to maintain the lead till the end? Define center of gravity. Okay, the point in which the entire weight appears to act on, okay? Not where the weight is located. It's different, huh? Oh, Ying still in the lead. I think it's the second last question already. This is not trial, huh? This is the early bird package. Meaning if you decide that, hey, I want to lock in tuition with Daryl today, what will you get? How many sets of curated notes? Is it 3, 2, 1? Okay, you get the exam kit, all right? So around a 30-page document that I've prepared for my own students, 3 sets of curated notes, as well as the priority in your selection when it comes to your time slot. Oh, Ying got dethroned. Oh no. Final question. Stable equilibrium. Meaning when I get displaced, I will still return back to my original position. It's C, right? D is neutral equilibrium, so don't get confused. Oh, who's the winner? Oh no, Ying dropped to 3rd place, but still a pretty commendable one. Okay, congratulations YL for winning. I think that was pretty sick. You got 10 out of 10 correct. Like, what the hell? Actually, Rachel did super well as well. That was pretty close. Okay, so whoever YL is, please drop me a text, okay? To tell me your name and your address, and I'll send you a set of the curated notes, okay? For everybody else, thanks for attending this session. I hope you learned something. If you have any further questions about the tuition stuff or you didn't get the free mini revision package or everything, you can check with me. I'll be around for the next couple of minutes if you all have any further questions. Okay?